Hi, grade 6 students. This is day 13, lesson 9-2, page 376, numbers 7 through 33, the odds. In a few seconds, I'd like you to pause this video and read carefully 374 and 375, and then come on back. Okay, hopefully you've read carefully those 2 pages that were just mentioned. You'll notice that today's assignment is a little bit about probability, but it's mostly about something called tree diagrams. Tree diagrams are a way of finding out how many different possible outcomes that can occur in a situation. What do we mean by that? Well, let's try to explain that. If you look, you will notice I have in my hand a white block and a red block. If I put those white blocks and red blocks in my hand and pick randomly what's the probability rather of getting a red block? Well, I got it this time. The probability is 1 out of 2. Favorable outcomes over the top of all of the outcomes is our definition of probability. And in this case, there were 2 total outcomes, red and white, and one of them was red, so the probability is 1 out of 2. Now, you had a number of circumstances that were given to you about tree diagrams and sample spaces. Let's see if we can apply that to a couple of example problems. We're going to start over here with this situation. Imagine that a couple gets married and they have 2 children. What is the probability that they will have 2 girls when they have 2 children? Or another way to say this is, what's the probability of getting a girl the first time and then a girl the second time? And we're going to solve this first by creating a tree diagram. When they have their first child, what are their possible amount of or type of child that they can have? They can have either a girl or a boy, right? When they have the second child, if the first child's a girl, what's their choices? They can either have a girl or a boy. But what if their first child was a boy? What are their possible ways in which they could have a second child? They could have a girl or a boy. This is what's known as a tree diagram. Right here, we have what happened in their first childbirth, and right here, we have what happened in their second childbirth. Now, what are the sample outcomes? They could either have a girl then a girl. They could have a girl then a boy. I'm just traveling the pathway. They could have a boy and then a girl, or a boy then a boy. Notice there's 4 different ways that they can have a combination of boys or girls in this situation. And so when we look up here and ask ourselves, what's the probability of getting a girl and then a girl, or in other words, 2 girls, it only happens right here. It happens 1 time out of a total of 4 times. So we used a tree diagram to find the probability of a couple having 2 girls. Let's look at this middle circumstance. Imagine you go to an ice cream shop and they have 3 flavors, strawberry, vanilla, and chocolate. And they also have 3 choices of toppings. They've got marshmallow, butterscotch, and fudge. What are the possible ways in which you could get ice cream at that shop? Well, first of all, choices of ice cream. You could have chocolate, vanilla, or strawberry. You only have 3 choices of ice cream. But now, how many different ways can you have toppings? You can have fudge, butterscotch, and marshmallow, no matter which variety of ice cream you buy. So, for example, you could have chocolate and fudge. You could have chocolate and butterscotch. You could have chocolate and marshmallow. You could have vanilla and fudge. You could have vanilla and butterscotch, or you could have vanilla and marshmallow. You could have strawberry and fudge, strawberry and butterscotch, or you could have strawberry and marshmallow. So we have 9 different ways in which a person can get their ice cream and toppings at this particular place if there's 3 ice cream varieties and 3 topping varieties. So if somebody said to you, in this case, what's the probability of buying chocolate and then buying fudge? The probability would be 1 out of 8. Nope, I'm sorry. 1 out of 9, because there's only one time where you see chocolate fudge out of a total of 9 possibilities. If somebody said to you, what's the probability of getting vanilla ice cream in your particular style of ordering ice cream and toppings at this particular store, the probability would be 3/9 or 1/3, because we've got these 3 choices that have vanilla out of a total of 9 choices. Let's go to this scenario on the right-hand side here. Let's move this a little bit. Somebody says to you, here are 3 coins, flip them all. What's the probability of getting 3 tails? What they're really saying is, what's the probability of getting tails on the first coin, tails on the second coin, and tails on the third coin? Let's create a tree diagram for this. On that first coin, they've got the probability of heads and tails. On the second coin, they've also got the probability of heads and tails. And on the third coin, they've also got the probability of getting a heads and a tails. If all of that's true, let's move that a little bit. The 3 coins could be heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. Notice right here inside the circle, that's our sample space. How many different ways did we find? We found 8 different ways to flip 3 coins. So what's the probability of getting 3 tails? Well, that only happens once down here. So the probability would be 1 out of 8. How about the probability of getting exactly 2 tails? Well, that happens here, it happens here, and it happens here. That would be 3 times out of 8. What's the probability of getting at least 1 tail? Well, this is at least 1 tail, this is at least 1 tail, this is at least 1 tail, at least 1 tail, at least 1 tail, at least 1 tail, and at least 1 tail. That's 7 out of 8 for a probability. Let's take a look at some of the problems that are on 376. I'm going to start with problem number 3 on 376. Follow along in your textbook as you look at the board up here. Problem number 3 says, the spinner is spun twice. Draw a tree diagram to represent that situation. Well, the spinner has on it A, B, C, and D. So if I were drawing a tree diagram, my first spin could be any of these 4 choices. Then on my second spin, I could also have any of these 4 choices. Uh-oh, running out of room. I might have to move this C down a little bit to give myself more room, and then also move the D down a little bit more to give myself some more room. What's my sample space going to look like in this case? It could be AA, AB, AC, AD, BA, BB, BC, BD, CA, CB, CC, CD, DA, DB, DC, and DD. So there's our sample space. Let's go to question 4. How many outcomes are possible? How many outcomes do you see? I see 16 outcomes. How about problem number 5? What is the probability of spinning 2 C's? Well, that only happens once right here, so that would be 1 out of 16. Any questions? Well, silly question by me. You can't ask any questions. Let's move on to number 6, which is talking about sandwiches. Problem 6 says, a neighborhood deli sells sandwiches that can be made with ham, turkey, roast beef, salami, or bologna. So how many different types of meat is that? That's ham, turkey, roast beef, and salami. Those are the types of meat. Wait a minute. Nope. There's also bologna, isn't there? Ay, ay, ay. And then it talks about the type of bread. That would be rye, white, pumpernickel, or sourdough. Rye, white, pumpernickel, and sourdough. So these are the breads, and these are the meats. And then it says, make a tree diagram to show all the possible meat to bread choices. So our meats are ham, turkey, roast beef, salami, and what was the last one, the B there? Bologna. And our breads are rye, white, pumpernickel, and sourdough. So how would I do that? Well, I'd have to create, in the first situation, a situation where there's 5 different types of meat that are all coming away from one point. So here's our ham, our turkey, our roast beef, our salami, and a bologna. And now going away from each one of these, I need our 4 different types of bread. Rye, white, pumpernickel, and sourdough. Now you'll notice I'm starting to maybe run out a little room here. I might have to scoot some of these down very quickly. Yeah, I think it's going to be worthwhile to do that right here. Let's move salami and bologna down a little bit. Let's put salami here and bologna here. Is that still fitting on the screen? Looks like it is. So we have enough room. So, okay, what are the different kinds of sandwiches? We could have ham and rye, ham and white, ham and pumpernickel, ham and sourdough. We could have turkey rye, turkey white, turkey pumpernickel, turkey sourdough, roast beef and rye, roast beef and white, roast beef and pumpernickel, roast beef and sourdough. We could have salami and rye, salami and white, salami and pumpernickel, and salami and sourdough, bologna and rye, bologna and white, bologna and pumpernickel, and bologna and sourdough. So that's number 6. Make a tree diagram to show all the possible choices. There's all the possible choices. In this particular case, we ended up with 20 different types of sandwiches that can be made. Okay, hopefully this helps you with this assignment. Feel free to give me a call if you get stuck. Thank you and have a good day.